So the final skill we're going to look at in this unit is solving quadratic inequalities. And I just want to make the note that these really require analysis. So what we see students do often, because you guys are really good at solving equations, is you act like these are equations and then you just kind of like plug in inequality signs. But that doesn't really make sense mathematically. Remember, our goal in this course is to build a better concept of what's happening. That requires lots of analysis. So normally when you guys look at something like this, something that you could compare it to is the equation that you solved. And you know that to solve this, you take things and you set them each equal to 0. So if we set x minus 4 times x plus 7 equal to 0, we know how to get the solutions because the zero product property says it's only going to happen if one of these things is equal to 0. So if x minus 4 is equal to 0, you'll get 0. So that's if x is 4. If x plus 7 equals 0, we'll get 0, and that's if x is negative 7. Those are your solutions. But those don't tell you exactly what's happening with the graph. What that means that you know is if you're thinking of all the numbers that x could be, you know that at negative 7, it will make it equal to 0. And at 4, it will make it equal to 0. Now, our inequality doesn't even say we want to make it equal to 0. These are important, so I'm going to circle them. The reason they're important is because think about what it's telling you about the graph of this quadratic. It's telling you that at negative 7, it hits the x-axis and at 4. And think about how quadratics behave. They either behave like this, or they behave like this. Okay, so what that means is that for every x in between the points, you're getting the same kind of y. You're either getting a positive y and it's making this portion up here, or you're getting a negative y and it's making the portion below. So my point in showing you that is to then show you too, like beyond those points, every x out here is either making positive y's or it's making negative y's depending on which way the parabola faces. Every x over here is either making positive y's or negative y's depending on which way the parabola faces. But the x's in those sections are making the same outcomes. They're not switching back and forth or it would cross back over the axis. What this means I know is that these zeros have split my axis into 3 portions. These 3 portions here. And I want to know how it behaves in those portions. So essentially, I want to plug numbers in. What happens when I plug in x in that's smaller than negative 7? When I plug it in here, what kind of values am I getting? Am I getting positive y values or negative y values? What happens when I plug x's in between negative 7 and 4? What happens when I plug x's in that are bigger than 4? So you're basically going to try it, okay? You're going to analyze what happens here. And since we only care, like, is it positive or is it negative, we are going to do what they call a sine analysis to see what happens. And what you're doing is you're thinking about plugging into this x minus 4 and this x plus 7, and you really are just wondering, is the result positive or negative for that certain x? So again, minus 4 and plus 7. So let's say that we plug in something from this first area over here where x is less than negative 7. Let's say we plug in something like negative 10. Your thought process is this. What happens? Well, negative 10 minus 4 is going to be a negative. Negative 10 plus 7 is going to be a negative. And when those two multiply together, the negative times the negative is going to make a positive. All the x's here are going to give me a positive y. It'd be different for each one, but I just care, does it turn out to be positive or negative? So what happens when you plug something in between negative 7 and positive 4? Let's say I decide to test 0. 0 minus 4 would be a negative. 0 plus 7 would be a positive. When the negative number multiplies the positive number, it's going to result in a negative. So all the x's in here are giving me negative values. Then it would cross back over at 4 where it hits 0, and I want to know what happens after 4. Big numbers, numbers bigger than 4. So let's say we plug in 5. 5 minus 4 will be a positive number. 5 plus 7 would be a positive number. The two positives multiplied together are going to result in a positive value. Okay, so here's my sign analysis. So my weird looking number line is now telling me, here's what you get when you plug in these x's. X is smaller than -7, you get positives. At -7, it's equal to 0. X is between -7 and 4, you get negatives. At 4, it's equal to 0. X is bigger than 4, you get positives. So now, which part contains my answer? Look carefully at the problem. What are you trying to get? Your inequality says you have something times something that you want to be less than 0. The kind of numbers that are less than 0 are negative numbers, meaning I want this multiplication problem over here to be negative. Those are the ones that fit this type of inequality and will show me my answers. So which ones were negative? These x's were negative. So my answer is which x's made it negative, and it's the ones between -7 and 4. So it is x's that are smaller than 4, but at the same time bigger than -7, and we write that in this compound inequality. So again, the 0 is key, just like with quadratic formula and factoring, because we can't really see what's happening if we don't do that. So each time you set one of these up, you want to compare it to 0. So I'm going to subtract 5 from this letter B. So I get p squared minus 4p minus 5 is less than or equal to 0. Now you guys need to work on your factoring. I'm going to factor this. If you don't know how this factored, you should pause the video and you should be factoring on your own to make sure you get the same thing. Okay. And remember, your factors give you key values. If p minus 5 was set equal to 0, I would get 5 as a solution. If p plus 1 was set equal to 0, I would get -1. So -1 and +5 are key points where my parabola would cross through the axis and things can change from being positive to negative. Now this time we do want it to be equal to 0. So these are part of the answer. 5's where it equals 0 and I want it to be equal to 0. -1 is another place where it's equal to 0 and I want it to be equal to 0. The next thing I need to do is my sign analysis. So remember what I'm testing. Something minus 5, how does that work out? Something plus 1, how does that work out? And then what happens when they multiply together? Is it positive or negative? So I'm first going to test numbers smaller than -1. So numbers in this section of my number line, I know they'll all work out the same because of the way that the parabola is structured, and I know that they're hitting the x-axis here. So let's say we plug in -3. -3 minus 5 would be negative. -3 plus 1 would be negative. The negative multiplied by the negative would make a positive. Right? And test section, the next section. X is between -1 and 5. So let's say I test 0. 0 minus 5 would be negative. 0 plus 1 would be positive. The negative times the positive would be negative. The last section, numbers bigger than 5. Let's say I try 7. 7 minus 5 would be positive. 7 plus 1 would be positive. A positive times a positive would be positive. So there's the analysis. I now know how this is working, and I now need to understand which part do I want for my answer. So I want to look back at what my problem is saying right now. It's saying two things are multiplied together, something times something, and I want them to be less than or equal to 0. The equal to is covered by including these points. The less than means that I want this result to be negative. I want negatives. Negatives will find my solution. So where did it work out to be negative? And this isn't going to happen every time. It depends on how you structure it, but my negatives came in here. That means my solution to this problem is that the p-values that are less than or equal to 5, but greater than or equal to -1, are the ones that solve this problem adequately. Now I'm going to look at part C. Again, I'm going to do the same setup. So the first thing I'm going to do is subtract 4 from both sides. And then you're going to work on factoring. So guess and check, your diamond in your box, whatever it is that you guys do to factor, but we should be efficient at some sort of way. So you should pause it if you can't get factors, and then of course just double check 6s squared minus, so mine looks pretty good. And these are gonna, if I set them equal to 0, I will get 1/2 and I will get -4/3. So the key values, or the places where I know this would be equal to 0 and then switch from possibly being negative to positive, are at -4/3 and 1/2. I don't want to be equal to 0. It doesn't say equal to in the inequality. So these are important points, but they are not part of my answer. And now I'm going to do that sign analysis. So again, I'm plugging something into 2s minus 1. I'm then plugging something into 3s plus 4, and I just want to know, is the multiplication going to work out to be positive or negative? So let's say I plug in something first smaller than -4/3. So something in this area. So say I plug in -5. 2 times -5 would be -10 minus 1, so that's a negative. 3 times -5 would be -15 plus 4 would be a negative, and multiplied together they'd be positive. Then between -4/3 and 1/2, maybe I'll try 0. This would be negative and this would be positive, resulting in a negative. And then beyond 1/2, so maybe I try something like 5. 2 times 5 is 10 minus 1, it will be positive. 3 times 5 is 15 plus 4, and those result in positives. Okay. And now I want to look at which part of this is going to answer my question. I want my multiplication problem up there to work out to be greater than 0. Numbers greater than 0 would be positives. So where I produce positives is where my answers would be, and that's here and here. And so the x values that are making those positive results are x's that are greater than 1/2 or x's that are smaller than -4/3. Those two highlighted areas on my number line. All right, so part D, we're going to do the same thing. I am going to write these in the order that is most comfortable for me. And this one is one of your perfect squares when you factor it. So hopefully you're able to see that. And that just means there's only one key value. D plus 4 is the only factor. So the one key value on that x-axis where it switches it up is at -4. Now, our equation does want to include where it's equal to 0. So we're going to include this. And now we only have two areas to test. Numbers smaller than -4 and numbers bigger than -4. And we are plugging them into this D plus 4 and squaring it. So when we do this, we plug in something to D. If we plug in a number smaller than 4, like say -8, -8 plus 4 will make a negative, but when you square that, it's going to be positive. Okay. Now if I plug in a number larger than 4, like say 10, 10 plus 4 makes a positive, and when I square that, it's a positive. So what am I looking for in my problem? When we look back at the problem, we wanted something over here squared greater than or equal to 0. So we already got the equal to by including the -4. Greater than 0 would mean that we want this to be positive. If you look at the places where it worked out to be positive, that is the entire number line because we're also including 4. So here, every number on that x number line is a value that we can use. So the solution here is all real numbers. There's no limitation on the x values to make that inequality true. All right, so then we're going to look at part E. E again factors as a perfect square. And again, if you're struggling with the factoring, you need to solve and check that on your own. Sign up for tutoring if needed. So when I check this, okay, the only value where it could be equal to 0 is with f plus 6. And that would give me -6. So the key number here is -6. I'm not going to include it because it doesn't say equal to here. And then I'm going to analyze what happens around -6. Okay, so remember what I'm plugging into is f plus 6 squared, and I want to check, does it work out to be positive or does it work out to be negative? Hopefully some of you guys are seeing the fact that it's squared kind of tells you the results right away. So I'm going to go ahead and plug in numbers smaller than -6. When I plug in numbers smaller than -6, let's say like -10, -10 plus 6 would make a negative, but when that's squared, it will be positive. Let's say I plug in numbers greater than -6, like 8. 8 plus 6 would make a positive, and when squared, it would remain positive. And then let's look at what we're looking for. So again, when we look back at the problem, we're looking for something that when we square it, it's less than 0, meaning we want this to be negative. And there are no negative results, not even at -6, because we didn't say we could be equal to 0. So here, none of the number line is shaded. There is no real solution to this. And then lastly, we're going to look at part F. Part F, again, factors as a perfect square. And again, if you have to, you should pause the video to see if you get the factoring right as a good check for you. Then when we look at this, there's only one 0 because of the squared, and that would be at 1/3. So 1/3 is our key value where the 0 is working there. And remember, we're testing to square 3v minus 1 and see if it's positive or negative. And now we're going to include 1/3 because it does say we could be equal to 0. So 1/3 makes the 0 and should be part of our answer. And now we're going to test. So if I test things smaller than 1/3, like say -2, -2 would make 3v minus 1 negative, but then it would square and become positive. And then let's say I test something larger than 1/3, like 5. 5 would make 3v minus 1 positive, and squared would remain positive. So here are our results. And then again, we need to analyze what we actually need to answer this question. What is the inequality saying? The inequality is saying you take something, you square it, you get a number less than or equal to 0. This will only be true if this left side is negative. Now, we don't have any negatives on our number line, but we were equal to 0 and included the 1/3. So even though we're not highlighting a portion of the number line, there was one answer to this that only exactly when v is 1/3 will get 0. We won't ever get the negatives, but that one solution will work for that problem.